If this is actually your first time of seeing these videos, we define automatic changeover to be a device that switches in between two sources of power, probably from your NEPA to your gen or your PSCN to your gen. Good day, ladies and gentlemen. Today, we want to build an automatic changeover using two contactors. If this is actually your first time of seeing these videos, we define automatic changeover to be a device that switches in between two sources of power, probably from your NEPA to your gen or your PSCN to your gen or to your solar, or as the case may be. But it's actually a device that switches in between two sources of power. Today's automation, we are actually going to build an automatic changeover using two contactors. Previously, we built an automatic changeover using a contactor, but today will be for two contactors. Now, the other components we are going to use, aside from the contactors that I actually mentioned, there are other components we are going to use, just like the timer, the relay, or as the case may be. But for this particular device, for this particular automation, we're going to make use of the contactor, the relay, and circuit breaker. So let me explain the device before we go over to building it. Okay, this is actually our contactor. We call this one K1 and we call this one K2. So representing contactor 1 and contactor 2. We can as well see the signal here, K2, K1. So in our contactor 1, you see that the power came in to the lines and then move over to the coil terminal of our relay. From our coil terminal of our relay, then energize the coil terminal of the contactor. Then from our lines down here, which is our generator supply, it goes over to the coil terminal of the contactor, and from there went to normally close terminal of the relay. Now let me explain it holistically. When our power comes in, with the way we configure this particular system, the power that is supposed to control the whole circuitry is this one, the NEPA we call the utility supply. Let me write it here. Utility, our utility supply. So utility supply means that it controls the whole system. It's actually a power that we don't have control over. It's a power that we don't have absolute control over. NEPA can come in anytime and leave anytime. So that's the reason why we actually make it the master of the device. Now, when it is only meant to control this particular relay, and if you watch very close, you will see that 11 is normally close to 8. This is actually for 11 pin relay, but since we are using 8 pin relay, let me change it. We are using 8 pin relay, so let me change it. So, okay. Okay, so if you look at the diagram very well, we are going to understand that when power comes into 2 and 7 of this particular relay, it energizes the coil terminal of the relay, but due to dependent on the certain time that we set this delay, it will now pass power to 3, turning this normally closed open to normally closed, and thereby energizing this coil terminal. So whenever it energizes the coil terminal of this contactor 1, which is for NEPA or utility supply, this power comes in and it will turn this place to normally closed, thereby taking out power from contactor 2. If we watch very very vividly well, we will understand that the reason why we added what can also as well replace what is here might probably as well be a timer that can switch, that has other functions that can switch in between two sources of powers, or that have several commons as well. So if we add a timer to this equation, or probably if we introduce a separate timer to this particular to this particular device, what you will notice is that the device will have to delay before it sends power to our automatic changeover or to our contactor. Why are we doing that? If you have actually read through the how to further authentify our component in introductions to automation, you understand that contactors doesn't always need to be surprised. Contactors don't need to be surprised. Excuse me. Contactors don't need to be surprised. So instead of you to surprise your contactor, or if you don't want to surprise your contactor, that's when you introduce a timer. But for what we are building now, we are using relay and not a timer. Having said that, let's go ahead, forge ahead. Now, generator supply can still be on while this guy comes and takes it off, while the contactor one comes and takes it off. But whenever power from this contactor one is no more available, the generator supply can now go in. If you watch very closely, you see that the T2 is tied to this T2, which is the load terminal of these two contactors. T1 is also tied to T1, which is also the load terminal of these contactors. And we can see that this is actually our load wire going probably to our distribution board or to any other device we are connecting it with. So lastly, the A1 represents the positive side of the contactor terminal, and then the A2 represents the negative side of the contactor coil. So whenever you see this A1 and A2, it represents the coil terminal of every contactor. Then whenever you see 2 and 7, it is the input of the relay. So when power comes into 2 and 7, it power and energize the relay. Let us also know that relay works with the principle of electromagnetism. It's actually the junior sister, or we can say the sister to actually the main contactor. But the difference between a contactor and a relay is actually the load both of them can bear. The difference between a contactor and a relay is subject to the load they can bear, and also is subject to the load they can bear, and also the outputs that they have. In the case of a contactor, we are talking about lines to lines, but in the case of a relay, we are talking about switching in between two sources of power, when we can use two-way switching pattern or three-way switching pattern. So having said that, having established that, let's go over to making this connection so that you see how it goes. Okay, here we are having the two contactors that we actually stated initially, with our relay base and also our circuit breaker. So what we want to achieve is actually to build an automatic changeover using two contactors. Building an automatic changeover using two contactors. So let's just go straight to making those connections. Now, if you look at our diagram, you will see very well that our lines came in. Our utility supply came in and connected to our lines. Okay, so for the matter of clarity, for the sake of clarity, this is our utility supply contactor 1, and this is our contactor 2 for our generator or any other alternative power supply. So we are actually going to make this connection to this and this. But before that, let's connect extra cable for energizing the coil terminal of the relay. So we are going to make extra connections to this wire so as to connect to the coil terminal of our relay. So that's the reason why we are making this connection. Remember, we are connecting it to the normally open of our contactor 1. From our normally open of our contactor 1, we then connect to the coil terminal of our relay. Okay. So we say that the coil terminal of our relay is 2 and 7. The coil terminal of our relay is 2 and 7. The coil terminal of our relay is 2 and 7. Let's also be aware that we can as well send power from here to we can as well send power from here to the coil terminal, the neutral line to the coil terminal of this particular contactor, which you can actually see up. Let's go ahead. Okay, more wire. We are looking at our diagram and then making the connections. Okay, so let's say this is our neutral. Can probably assume, please be careful of your polarity. Be careful of your polarity. So it's connected to 7. Okay, let's use that large since it's closer. Connected to 7, then from 7 to the coil terminal of our contactor. Okay, the cable we presume to be neutral is what we're making connections for, and we're connecting it directly to from there to the coil terminal, the neutral line of our relay. Okay, you can send wire here or you can send it down. Send it down, it will come up. Okay, okay. So connect it to A2, A2 of our contactor, A2 of our contactor. Okay, so from our A1, it goes to number 2 of our contactor. From our lines, we loop from 2, we loop to 1. So in this case, 2 to 1. Okay, remember we are still working on contactor 1. Contactor 1, that's where we are still working on. Then we take another cable, we take another small cable, small one, and then take from 3, 3 of the relay to the coil terminal, A1 coil terminal of our contactor 1. Okay, you have established that. Let's go ahead. Okay, okay, let's go ahead. So now, if you look at this diagram very well, you will understand that we have completed every connections we needed to do at the contactor 1 side. Now there is something that we omitted, which we are going to quickly correct. Remember that we said we want to use this breaker to control the power that comes into our contactor. So let's quickly do that and then readjust. Okay, okay. So another cable. Okay, so we can take from here, since we want to use the breaker for our NEPA supply, so that it will have some level amount of protection. Okay, so if I've done that, you can then connect these both together and take them in. So the cable sizing, please, while embark on any automation system, make sure that you have already gone through other things we discussed while before we started building our automation system. So we are done with everything on the contactor one side. Now we are going over to the contactor two side. Now the first thing we are going to do is these are generator cable. So we are going to connect it. When we connect it, we will send them one wire from our live, the positive, from the negative to the coil terminal of our contactor one, and then from the positive to our relay. So remember that your connection is supposed to be at the normally open side of your contactor two. So find out the number and connect. In my own case, I have 40, I have 43 and 44 as my normally open. I have 43 and 44 as my normally open. I have 43 and 44 as my normally open. So it will go from here to the terminal number 8, which is common to, which is normally close to 5 and normally open to 6. Normally close to 5 and normally open to 6. Normally close to 5 and normally open to 6. Then we connect another cable from here to the neutral side of our contactor 2. So find out the one that is normally close and connect. In my own case, I have 13 and 14 to play with. Normally open. Find out the one that is normally open. In my own case, I have 13 and 14 to play with. 13 and 14. So these two here are normally closed. Why here and here are normally open. So you must be sure of what the terminals you are connecting wires to, so as not to make any mistake. So as not to make any mistake. Okay. Okay. So the next thing here is to connect the remaining cable from number 5, which is normally close to 8, to A1 coil terminal. So we connect to A1. From number 5, we connected to A1 terminal of our contactor 2. So having done that, this system is complete. Now there are other status you can add, or there are other little things you might decide to ask. Just like you might decide to add, probably you might decide to add your indicator lights. You can decide to add switches and so on and so forth. So with this, we are done with our connection. So what we just need to do is to plug this in, and that is it. Now what we are going to do is to add the loads. What is remaining for us to do now is to add the loads. Once we make the connections of the load, the device will be complete. So on the load, we just need to connect. On the load, we just need to connect them from the side of the generator to the side of the. Remember, we have lots of cable connectors that we use to cable locks that we use to make connections to these wires. But due to we are not making use of the correct gauge of the cable we are supposed to use, that's the reason why we are supposed to use. That's the reason why we are kind of terminating it without those connectors. But we are going to show you guys how those connectors look like so that whenever you are embarking on your own project, you will remember to add them up. You remember to add them up. So we are now making connections from our load to our load. So any power that comes in, it can power our load. Any power that comes in, it can power our load. Okay, okay. So we are good to go. So what we are going to do now is to use our digital multimeter to check whatever we've done and see whether there is any how probably we've made a mistake from our diagram. So after testing that out, we will now after testing that out, we will now power our system. So let's check. Okay. So we first of all check for, let's remove our relay first. There is a lot we need to check from here. So first of all check to the coil terminal passed. So we actually check from there to, okay, we check here, okay, okay. So we check from here to here, we check from here to here, okay. So we check from the load to the load, we check the load to the load, okay, we check two load, okay, check two load to see whether they are in any way connected together, okay, okay, very empty, and our system is set to be tested. Our system is set to be tested. Our system is set to be tested. Okay. So we plugged in our relay, and now is the time for us to test our automatic changeover using two contactors. Okay, viewers, let's quickly look into what we have built. After measuring all our cables and checking whether there is any mismatching or wrong connection of cables, and we certify it to be okay, we want to now test. Now let's say for example that your generator is on. Ideally your generator is on, and then they resume power. So look at the breaker that connects our power to the automation. So if this breaker is not on, ideally you need to turn it on. But this is why we added breaker, so that if there is any electrical surge, it should be able to trip up by itself. So when I turn it on, you can see how it changes from NEPA. It changes from generator to NEPA. NEPA is now on, it's now inside. When I remove the breaker, this guy goes in. You can see how it goes in. So you will notice that when you take off the generator cable, the power is still on. This is our load. Power is still on. But if this is introduced to the system, if you take out the NEPA, which is this, or even if you plug it out from here, you see that NEPA takes over. And when you now takes over the gen, the system goes off. So this is a complete automatic changeover that can switch in between two sources of power using two contactors, one relay, and a breaker. Remember, before you embark on this project, make sure you size your cable, make sure you size the load, make sure you use the appropriate cable sizing, and make sure that you adhere to safety precautionary measures before embarking on this system. I hope this helps. Bye.